pH of human blood and its control. This is today's lesson. In this lesson, we are going to discuss pH value of human blood, importance of pH, and finally, mechanism of pH control. So, let's begin. First point is pH value of human blood. Let's look at the matter. Human blood is a kind of buffer solution of carbonic acid and sodium bicarbonate. Here, carbonic acid is a kind of weak acid that dissociates partially to form proton and bicarbonate ion, and basic salt of carbonic acid, sodium bicarbonate, is a kind of strong electrolyte. So sodium bicarbonate dissociates completely to form sodium ion and bicarbonate ion. We know Henderson-Hasselbalch equation for calculating pH of buffer solution is pH is equal to pKa plus log of concentration of salt divided by concentration of acid. Using this equation, Henderson-Hasselbalch equation, we can calculate pH of buffer solution. Human blood is a kind of buffer solution of carbonic acid and sodium bicarbonate. In human blood, concentration of salt is 24 millimole per liter. Here 24 divided by 1000 mole per liter, that is molar. Again, concentration of acid in human blood, that is concentration of carbonic acid, is 1.2 millimole per liter, that is 1.2 divided by 1000 mole per liter. Again, pKa for carbonic acid is around 6.1. Putting these values in the Henderson-Hasselbalch equation, we get 6.1 plus log of 24 by 1000 divided by 1.2 by 1000. Finally, 7.4 is obtained. So pH value of human blood is 7.4, which is a bit basic in nature, because here this salt is of strong base and weak acid. That is why it is a bit basic in nature. So pH of a human blood is 7.4. What is the problem if it decreases or increases? That is importance of pH. Let's see now significance of pH. Now, importance of pH of human blood. We learned that pH of human blood is 7.4. It can vary from 7.0 to 7.8 by decreasing 0.4 or by increasing 0.4. That is, plus minus 0.4 is acceptable. But when it goes out of 0.5, then life becomes critical. When pH value is less than 7.0, then this condition is known as acidosis of blood. And when pH is greater than 7.8, then this condition is known as alkalosis of blood. This condition, that is acidosis or alkalosis, can lead to death. So, significance of pH is unavoidable. Controlling pH value is very much important. But this pH value may change in this way. 7.4, this value may decrease for taking lemon juice that contains citric acid. Again, this pH value may increase for taking antacid that contains magnesium hydroxide. So, for taking foods or medicines, pH value may decrease or increase. But blood is a kind of buffer solution that controls pH value change. Now let's see mechanism of pH controlling by blood itself. Now the point is pH control by blood. We know blood is a buffer solution that contains carbonic acid and sodium bicarbonate. Carbonic acid is a kind of weak acid that dissociates partially to form proton and bicarbonate ion. Salt of strong base sodium hydroxide and weak acid carbonic acid, sodium bicarbonate salt, is a kind of strong electrolyte that dissociates fully to form sodium ion and bicarbonate ion. That is, suppose this is blood that contains proton, bicarbonate ion, sodium ion and carbonic acid. Carbonic acid is present there because it's a kind of weak acid. It doesn't dissociate completely. That is why blood contains carbonic acid, proton, bicarbonate ion and sodium ion. When we take acidic substance like lemon juice, then concentration of proton is supposed to increase on addition of proton, but it doesn't increase because this proton combines with bicarbonate ion to form carbonic acid. Carbonic acid is a kind of weak acid, so this carbonic acid doesn't reproduce proton. That is why concentration of proton remains unchanged and no change in the pH value, because we know pH is equal to minus log of hydrogen ion concentration. pH value depends on the concentration of proton. Here, concentration of proton doesn't change. Additional proton combines with bicarbonate ion to form carbonic acid. Carbonic acid is a kind of weak acid. It doesn't reproduce proton. That is why concentration of proton remains unchanged ultimately, and no change in the pH value. But if we add hydroxide ion, that is, if we take basic substance like antacid, then this hydroxide ion combines with proton to form water. So this proton combines with hydroxide ion to form water, and for this reason concentration of proton is supposed to decrease, because proton is combining with hydroxide ion, but concentration of proton remains unchanged, because when here concentration of proton decreases, a gap is created here, and in that case undissociated carbonic acid dissociates again according to Le Chatelier's principle. Ultimately, concentration of proton remains unchanged, and then no change in the pH value. That is, blood itself controls its pH value. This is all about pH control by blood itself. No more today. Thank you very much.